Well, this morning I'm here to talk with you about a subject which almost certainly every one of you has interest in, not just for yourself but for your loved ones, simply because it is to do with a condition that is right at the top of the list when it comes to those diseases that take lives in our society. What I want to talk about with you is heart disease, or cardiovascular disease, or stroke. I think I would like to begin by trying to define exactly what those things are. So a little bit of touch here on anatomy and physiology, just briefly. Your heart is essentially a big pump, and what your heart does is it processes air, if you like. It takes different gases in different directions around your body. Its main function is to provide the cells of your body with oxygen, and it does this by pumping the blood around, because the blood is containing oxygen that you breathed in, and it delivers those oxygen molecules to the cells of your body where they're needed. At the same time, it takes carbon dioxide, which is a waste product of ours, and transports that gas out of your body. So really, it has two jobs: the oxygen in and the carbon dioxide out. And in fact, your heart does have two distinct sides. When we talk of the left-hand side of the heart, we're talking about your left, not left as I look at you, but your own left. And the left-hand side of your heart is a big pumping chamber that sends blood around your body carrying oxygen. The right-hand side is the side that takes the carbon dioxide and pushes that up towards your lungs, ready to be breathed out. Now, it's rather interesting that the heart, because it has two jobs, is in two parts. Those parts technically could be on opposite sides of your body. They could actually work independently. They don't need to be connected, but they are. There is, however, a central division that keeps the two gases and the two sides totally separated. Now, what's important to remember about the heart is that the heart is a muscle. And because it's a muscle, it needs its own blood supply. And it's supplied through vessels called coronary arteries. And they go round the heart like a crown, hence the fact they're called coronary arteries. And these arteries are vital because if the heart itself doesn't get its own supply of oxygen and its own carbon dioxide taken away, the heart can't function. So anything that impedes the circulation of the heart can lead to angina, which are the warning signs a heart attack's about to happen. They're the crushing pains you can get in your chest that's transient and passes away. But those signs are telling you there is a blockage occurring. There is not enough oxygen getting through to your heart through these coronary arteries. You can also have a problem with your brain. Your brain also needs a constant supply of oxygen. And if it doesn't have that constant supply, it starts to die off in parts or become non-functional. If oxygen doesn't get to your brain, then we call it a stroke. And there is a technical term for a heart attack and a stroke. The technical one for the stroke is cerebral infarction, and the technical term for a heart attack is myocardial infarction. Now, just the way we get angina, those crushing pains in the chest, to warn us that we might be going to get a heart attack, we can also have warnings that we're going to get a stroke, that the oxygen is being cut off from the brain, and that's called a TIA, or a transient ischemic attack. And again, that's a little warning. It can often last for only seconds or moments, and it's suddenly having slurred speech or getting paralysis on one side just temporarily. But both angina and TIAs are warning us that if we don't do something, we're going to go ahead and have a full-blown heart attack or a stroke. So what causes these conditions? Well, as I've said to you, the heart, and also in fact the brain, are supplied by arteries with oxygen. And if these arteries start to become blocked up, that's where the problem occurs. So what is the makeup of the artery and how can it get blocked up? Well, the arteries are actually different from veins in the way that they're designed. Arteries have great, big, strong muscular walls, and the idea is that these muscles contract and push the blood through the artery, through the passageway. Veins, on the other hand, have much thinner walls, and they have valves intermittently, so that when the blood goes through the vein, the valve shuts behind it, and the vein effectively climbs up as if it were a step ladder through your veins. But your arteries pump and push, yeah? So anything that stops those muscles working, or anything that blocks up the hole in the middle, is going to be a problem.